If we have ways to produce electricity in a clean way without harming the environment, why don't we do it? Well, the answer to that's quite obvious. They are expensive and they require special resources. Take wind turbines and solar panels, for example. If there's no wind and sun, well, there's no electricity, and there's nothing you can do about that. Well, they're not the same as this a hydrogen fuel cell. And as you may know, it only requires one thing to run water, or you could just use plain hydrogen and oxygen. So, how does this thing even work? Well, this type of fuel cell is known as a polymer electrolyte membrane fuel cell, or a PEM fuel cell, and consists of three main components an anode, a cathode, and an electrolyte membrane sandwiched between them. Now, our fuel cell first goes through a process known as electrolysis, and electrolysis is defined as the use of electric current in order to produce a chemical reaction. Now, our fuel cell first does this when it is provided water through the gas capture PEG, which I'll get more into detail on later. Our fuel cell then takes that water and splits it into hydrogen and oxygen. Our hydrogen goes to the cathode side, while our oxygen stays on the anode side. And from those two places, they are collected in our syringes connected to the two gas captures on the side. Now, the second step our fuel cell goes through in order to create electricity is to use the hydrogen and oxygen collected in our syringes to create it. The hydrogen on the cathode side enters the fuel cell and meets with the electrolyte membrane, where it is then broken into protons and electrons upon contact. This process is known as a redox reaction. Redox reactions are a type of chemical reaction in which a state of atoms are changed, and in this case, our atom is the hydrogen being turned into protons and electrons. Now, the electrons are not able to pass through the electrolyte membrane, so they travel via an external circuit to create our electric flow that we use as electricity to meet on the anode side, whereas the protons just pass through normally. It is on the anode side where all three, the protons, the electrons, and our oxygen, meet up to produce H2O, or just clean water. Also, remember what I said about the gas capture? Well, this is the PEG at the top left, near the black and red circles, and is simply where water enters for electrolysis and where the gases are captured and released into the fuel cell from. There are also other connections on this fuel cell, which include the electrical connection, which is where the black and red circles are, and these are where you put your gold pins to allow the flow of electricity to take place, and where that external circuit leads to. And the other connection is the pressure release point. Now, when I was building the body, I had two things in mind, which was designing it to be light and sturdy. I accomplished this effort by using a thick piece of plastic board to create the body and the parts that would hold the back axle, which was perfect. I went through about two prototypes, with the first one looking completely terrible and barely working because of the poor support of the front motor, and the other one ended up being the design I was going to use, except it looked like a 4-year-old had made it. For my final design, as you can see, I went for a samurai theme with a little helmet and everything, which is probably my favorite part. And to be honest, it ended up looking really great. So now it's time I talk about some of the engineering choices I made. I decided to stick with syringes instead of a balloon, which I was planning originally, but I realized that they create a lot of air resistance and look pretty bad overall. However, I decided to also make the rubber tube connections as small as possible. This was because I realized that when filling up the syringes, they would go faster if the tube was shorter, so I decided that it would probably be best to have a shorter connection so that it can also get to the syringe faster. However, the design choice I'm most proud of was for the wheels. I went with two small plastic wheels in the back and a large skinny wheel in the front that was directly connected to the motor. Now, the main reasoning behind this is that it ensures I have the least amount of energy lost. This is because if I use two wheels, I would need to use gears. And the problem with gears is that whenever energy is transferred, it a little bit always gets lost. So each gear I would use would always take away some of the energy in the motor, which would have gone originally to pulling the car forward. So that is why I chose to stick with connecting it directly to the motor and with one wheel. Also, the design choice for the back wheels being the small plastic ones was because they aren't contributing to moving it forward, and having them small and light and made out of a slippery material like plastic makes it easier for the front wheel to pull it forward, ensuring that the fuel cell's energy is put to the most use. However, before I went somewhere more open to test out my car, I decided to do a test run within my hall. So I set up the fuel cell as normal, started it up, and nothing. My fuel cell was not putting out enough energy to even make the car move, even with my light design. I tried many things to fix this. I switched out the batteries, changed the cables, shortened the tubing, switched the pins, made sure that my tubing was tight, and even got a new fuel cell, but to no avail. However, I did notice something. It was only when I switched the syringes out for smaller ones that it would start out with a powerful spin forward, making the car move. That would last about 3 seconds, and then it would slow down to the same speed, making the car unable to move. So what I took from that was that the syringes were somehow the problem. I went through a bunch of combinations of large and small switches, and still nothing, until then I decided to just get new syringes, and if that didn't work, then I didn't know what to do. So I finally did get new ones. I put them together, started the car up once again, which actually finally convinced me to give up. Yeah, it was at this point where I was running out of time and I knew there was no way I could figure it out by the time I needed the footage for. However, I'm still glad with the progress I made, and I feel like if I did get it to work, my car would actually run pretty well. So in summary, I want to go back to the question I asked in the beginning. Why don't we use hydrogen fuel cells today? Even though they are easily and cheaply refueled, don't require any non-reliable fuel, they are green energy, and unlike diesel motors, they are not loud or produce fumes. Well, there's actually a simple explanation for this, and there's not enough demand for hydrogen-powered cars. Consumers refuse to buy cars that are powered via hydrogen if there are going to be no pumps to refuel them, and the gas stations won't build more pumps to refuel these cars if there's no consumers that are going to use them. So it's kind of stuck in a loop at this point. And even though it's probably the best shot at a low to no carbon future, it's just as it is. There's nothing we could do about it until either one side decides to build more or the consumers decide to buy more. Anyways, thank you for watching.